So today we are going to be working with quadratic word problems, which we call projectile motion problems. And quadratics are used a lot in real world situations. So, for example, this picture here is a picture of the St. Louis Arc, and this is an architectural version of a parabola. And did you know that parabolas are pretty much everywhere? You can see them everywhere, although you may not always realize you're seeing them, they're actually there. So, we use parabolas to represent all kinds of real life situations, and we use quadratic equations to model them. So for example, kicking a soccer ball, it will make the shape of a parabola. Same thing as passing a football, it will also make the shape of a parabola, but it will be a very wide parabola. Same thing as hitting a baseball. Jumping off a cliff, this will be like half a parabola from its maximum on down. Diving into a pool, water gushing out of a fire hydrant, the water will make the shape of a parabola, whether it's a little one or a very big one. And another example would be a rocket being launched into space. The launching part and the landing part will make the shape of a parabola. And lastly, company profits can be modeled with quadratics as well. So let's take a look at some situations where we can represent a quadratic equation and use what we know about parabolas to make it happen. Alright, so actually we don't want to do this one, we want to do the one on our paper. So we're going to be looking at a word problem, which is this formula given to us with negative 16x squared plus 160x gives the height above the ground in feet of a paper airplane. After how many seconds does the paper airplane hit the ground? So what is being asked of us? Because we know certain things about a parabola. We know how to find the vertex. We know how to find the zeros where it hits the x-axis, and we can figure out a random height. So those are the three main things we're being asked for. In this case, we are being asked to find when it hits the ground. So we want to find the solutions or the roots or the zeros, however you want to call it. So in this case, here's our paper airplane, sorry. And it goes up and it comes down. And we want to find this spot right here when it hits the ground. So visualizing on an XY plane, we want to see where it hits the ground. So we're going to have two zeros, one at 0 and the other one somewhere else. That's the solution we're looking at. So we can solve a quadratic and set it equal to 0. So our goal is, when does h of t, or h of x here, equal to 0? So actually I have it wrong, h of t, or h of x. When does this equal to 0? So I'm going to write my equation down, negative 16x squared plus 160x. And when does this equal to 0? So I know there are three ways to solve a quadratic. I can do the quadratic formula, I can factor, or I can complete the square. In this case, I'm going to factor. It's usually the easiest one. But before I start doing my x factor, I am going to go ahead and factor out a GCF. I can notice that both of these are divisible by 16. So I'm going to factor out a 16. And I'm going to make it negative, so whatever's left over starts with a positive, and I can use my shortcut. So, and actually, I can also factor out an x. They both have an x in common. And I may not have to use my x factor in this case. So if I take out a 16, I'm going to write this in the bottom, 16 for two x's. If I take out 16 and negative 16 and one of the two x's, I'm left over with a single x. If I factor out a negative, or double negative makes a positive, that will be 16 times 10. So that will leave me a negative 10. And that equals 0. Because 16x times x is 16x squared. Negative 16x times negative 10 gives me a positive 160. So in this case, I don't actually need to use my x factor anymore. After all, I don't need it. I've already factored both pieces. I'm going to solve for x on each one. So the first one's pretty easy. What makes this equal to 0? When x is equal to 0. If you plug in a 0, it eliminates the whole thing. What makes this one equal to 0? When x is equal to positive 10. So these are my two solutions. This is at 0 here and at 10 here. So it takes 10 seconds or so, and I'm assuming we're in seconds here, I didn't actually write it out, to hit the ground. So the answer would be After how, oh, here it is, seconds. After how many seconds does a paper airplane hit the ground? So it will take 10 seconds. So we'll just write in a quick sentence. It will take 10 seconds for the paper airplane to hit the ground. All right, so we have our answer for the first one. It's taking us 10 seconds for this paper airplane to hit the ground. So main thing about these problems is to be very careful to make sure you are answering the question they're asking us. In this case, when it hits the ground, it's one of the roots. So let's move on to the next problem. This next problem is asking, let's see, Angela kicks a soccer ball in the air. We have this equation. H represents the feet, T represents the time. What is the maximum height that the soccer will reach? So how high will this soccer ball go? So thinking about what it's asking us and how long will it take for it to reach this height. So two things, they're asking us two questions. What's the maximum height and how long will it take? So just doing a quick little sketch here on the side. Here's my soccer ball being kicked. It goes up, it comes back down. And here is the maximum at the very top. So this is the max right here. So essentially what they are asking us is the vertex. So that's what we're trying to find. So when it says what is the maximum height, that's vertical height. That would be the y value. So y is the height. I'll put h for height. And how long will it take to reach this height? So going across, how much time will it take? So that's going to be our x value, which will be the time. So height would be the vertical, time would be the horizontal, and height would be the y value. X is the time. So if we find the vertex, those two values will give us our solution. So let's go ahead and find the vertex. And we know how to find the vertex. X equals negative b over 2a. We've done this many times. In this case, it's not x equals, it's going to be time. So let's put t equals because this equation is in time. So it's negative of b over 2a. So again, this right here, the equation, these right here are my a and my b. All right, so my b is 64. I'm going to plug in a 64. My b is negative 16. And that gives me 64 negative divided by 32 negative. And we're going to simplify that. Actually, let me just clear this out just to make it neater. I'm going to clear out the part in red. So I just quickly rewrote this for it can be neater. So our x, or our time, is negative 64 over 2 times negative 16, which gives us negative 64 over negative 32. Divide that, you get positive 2, and this is going to be in seconds. And then we take our 2 and we plug it back into our equation. So we're going to plug in 2 into our h of t, which is really our y. So and I forgot to write something down. Let me go back and fix that. All right, so we're going to plug in our number 2 here and there. We have 2 t's for time. We're going to go ahead and simplify this. We've done this many a times. We're going to get 16 times 4. That's negative 16 times 4. Plus 128. We multiply them, we get y equals negative 64 plus 128. Do our check. 64 is half of 128, and 1 is negative and 1 is positive, so our y equals 64 total, and it's going to be in feet. So answer to our question is, how long? What is the maximum height? It will be 64 feet. The time will be 2 seconds. So it takes 2 seconds to reach the maximum height of 64 feet. I'm going to write that out. So I accidentally cleared out the work, but you should have it. You can always rewind it to see it. So here's our answer. The maximum height is 64 feet after 2 seconds. We're going to go ahead and graph this. So since it's 2 seconds, I'm going to put tick marks on my graph after every 2 boxes. So 2 boxes will be 1 second. After 2 boxes to the right, it will be 2, 3, 4. I'm just going to mark up to 5. And then going upward, since I want to go to a maximum height of 64 feet, I am going to go by 8, since 8 is a factor of 64. So every 2 boxes, I'm going to make it 8. 2, and I'm going to put 8 tick marks. 1, 2, 3, 4, 5, 6. And actually, I don't have enough to do 8. So let's go ahead and let's do every one will be 8. So I'm going to go 8 going up. 1, 2, 3. Actually, let's just go off the grid. It actually looks nicer. So it's going to be 8, 16, 24, and so on. And I'll just do one more off the grid. So this will be 8, 16, 24, 32, 40, 48. Then we have, what, 56 and 64. So we're going to go ahead and at 2 seconds, we're going to graph our point. So after 2 seconds, the parabola reaches 64 feet. So it will be somewhere right there off the grid. And we know the soccer ball was on the floor at the beginning at time 0, so we're going to put a point right here. And we're going to connect that. So there's half my parabola. I'm going to reflect the other half. I know it's symmetrical. So if it took 2 seconds to go up, it's going to take 2 seconds to come back down. I'm going to go ahead and graph the other half of the parabola. And I have my parabola graphed. Let's go ahead and move on to the last problem. All right, let's see what this last problem is asking us. This formula gives a height h above the ground in feet of a launched cannon. And when will the cannonball be exactly 80 feet off the ground? So let's say we have our cannonball. It shoots up, it comes back down. And I don't know if it's the maximum, so I'm going to assume it's going to be somewhere like right here. Let's say this is our 80 feet mark. So we're looking for a specific height. When is h of t going to be 80 feet? So I'm going to replace the h value for the number 80. So I'm going to take my equation right here. I'm going to rewrite it. H of t equals negative 16t squared plus 96t. And I'm going to set this equal to 80 feet. When does this equal 80? Now I'm going to go ahead and solve this. We're going to solve for t and figure out when does this make it, what t value makes it equal to 80. So in order to solve a quadratic, again, I have 3 methods: quadratic formula, completing the square, or factoring. I'm going to move the 80 from the right side to the left side. I'm going to drop the h of t, so negative 16t squared plus 96t. Subtract 80 on both sides. So minus 80 equals to 0. So since I have an equation here that's equal to 0, I'm going to see if I can divide everything by a number to make everything smaller. These are all divisible by 16. So I'm going to divide everything by 16. Actually, I'm going to divide everything by negative 16. Just to make it positive at the front. So when I go ahead and divide everything by 16, I get t squared plus how many 16s go into 96? And actually it's not a plus, it's a minus because I'm dividing by a negative. That's going to be 6t. 80 has 5 16s into it, and again all signs switch because we are dividing by a negative. So the question is, can I factor it, or should I be using the quadratic formula or completing the square? I'm going to draw an x real quick. I'm going to put my 5 at the top, negative 6 at the bottom. 5 times 1 is 5. But in order to make it negative 6, both of them have to be negative. I can definitely factor this. I can use my shortcut. So t equals 5. I'm sorry, t minus 5. And t minus 1 equal to 0. And in this case, we have our two solutions are going to be t equals positive 5. And again, all answers should be positive because we're talking about real world. So this is telling me that at time equals 5 seconds and at time equals 1 second, the cannonball is 80 feet off the ground. There are two solutions. Remember, it's two spots where you're going to get 80 feet as it's coming up. That's at 1 second, and as it's coming back down at 5 seconds. And if we had the same solution twice, it would be at the vertex. But in this case, there's two different solutions. So we have two spots where the cannonball will be exactly 80 feet off the ground. So I'm going to write the sentence out for that one. All right, so here's our final answer. The cannonball will be at 80 feet after 1 and 5 seconds. All right, that's pretty much it. Just be very careful as you're solving these problems. Decide whether they're asking for the vertex, whether they're asking for the zeros, or a specific number where you solve by factoring or by finding the vertex. All right, go ahead and start your practice problems, and good luck.